Hello friends, uh, let's see the packaged boiler in this sixth lecture of steam and steam boiler, which is third unit of thermal engineering. Okay, in last lecture uh, we saw two boilers, Lamont and Loeffler, okay, which are forced circulation and high pressure boiler. Okay, its advantages, disadvantages and application, different working pressure and steam generating capacity, all these aspects we have studied. Now let's see what is a packaged boiler. uh, Packaged boiler is a factory made boiler that available in wide range of standard designs. These are water tube or fire tube boilers. These are used for heating as a steam generator for small power purposes such as self-power industrial plant and not applicable for large scale power plant such as cogeneration plant because of size and boiler efficiency. Okay, it mainly consists of steam pipe, water pipe, fuel supply, electrical connections, and can be made ready almost immediately. Okay, that means for any organization, if you require, like in most of the rubber industries, you need the boiler, okay, for generating steam and high pressure, and there you need temperature also. Okay, at such industries you need a boiler, but not that much big as we use it for uh, electricity generation. So packet boiler is of that kind, okay, in which you have to generate the steam, okay, which is not used for production of electricity but for other purposes. Okay, now so these are quite smaller, which may be fire or water tube. These are used for heating as steam generator for small power purpose such as self-powered industrial plant and not applicable for large-scale power plants such as cogeneration plant. Because of size and boiler efficiency, it mainly consists of steam pipes, water pipes, fuel supply, electrical connection, and can be made ready almost immediately. The chimney used in these particular boilers are of type masonry chimney, steel tube, or and stack is provided just sufficient to clear the nuisance of the exhaust gases, and burner provide its own draught fan. Okay, packet boiler are fired from fuel oil. Okay, generally in bigger boiler where we have to generate electricity, we use the coal. Okay, actually we use coal for the generation of steam, and but in this packet boiler, as these are smaller one, and the oil can give us a better fuel efficiency. That's why we can use oil over here, or gas, okay, and not require filter as they burn consistently, removing all contaminants within the fuel. Fuel is ignited in the burners, which create an explosion within the boiler. For continuous combustion within the boiler, fan forces air into the burner, creating turbulence to keep the flame ignited and the furnace pressurized. Okay, what are the advantages? Okay, let's see. Easy installation and compact design. Okay, as these are the smaller one. That's why this one is easy to install, and design is also compact. Then a requirement of manpower is less. Then complete combustion due to forced draught. Okay, as forced draught draws more air. Okay, more, or we can say sufficient air efficiently. That's why the combustion takes place very well. Less cost and more efficiency than other boiler. Okay, then high thermal water level and less environmental effect than other boiler. Right. Less cost and more efficiency is why, because there is we can say low as boiler plant is small, that's why there is losses of the energy due to different mean will be very less. Okay, that's why this the less cost and more efficiency of this boiler can be there, then high thermal air level, and then less environmental effect than other boiler, and it burns less fuel as compared to other boilers. Disadvantages are complicated construction. Okay, as this is smaller, construction is smaller, complicated, but the installation is what, simple, because you just have to put it into working. As complicated construction you have already done. A high initial and manufacturing cost, and tube cleaning is difficult. It is a smaller one type of package boiler, the A type package boiler and the D type of package boiler, and there is also another one, O type. Okay, it consists of A type boiler. It consists of two water drums and one steam drum. Water boils in the water drum shared by a common heater. Okay, it consists of two water drums and one steam drum. Water boils in the water drum shared by common heater. Okay, that means same water is fed to both the one, then sent up to the generating tubes into the steam drum. Then that's D type is what? It has a single water drum and steam drum and generating tubes. Water flows water drum through the generating tubes. Here, the fire is located around the casing water molecule to boil off into steam. Steam rises up in the generating tubes and back into the steam drum. In this way, the steam is generated. And the third one is the boiler, O-type boiler. Uh, it has two drums, one water drum and one steam drum. The combustion chamber is in the middle, surrounded by downcomers and generating tubes. Steam generating tubes are arranged on both sides of the steam and water drums. When water boils due to convection heating, steam rises up through the tubes and into the steam drum. Next one is boiler draught. Okay, let's see what is boiler draught. First of all, after combustion of fuel, the uncombusted gases, or we can say that in case of coal, burning of coal, soot particle, different type of gases, carbon dioxide, carbon monoxide, different oxides of sulfur, oxide of nitrogens. So these are the byproduct of combustion. So this must be draw out of that furnace easily and efficiently, because if it accumulate in the furnace, it will reduce the combustion efficiency, or even it will not let the fuel to burn. Okay, because it will occupy the position of oxygen, and it will not let that fuel for or it will not let that fuel combust. Okay, in this way, or this soot particle will reduce the efficiency of the boilers. Okay, that's why we have to draw it out of the boiler, this soot particle or whatever gas is generated, or few gases is generated in the boiler. You have to exhaust it to the environment to the sufficient height even. Okay, because if it is exhausted to the lower height, it will result in different diseases to the nearby villages, and even the person working in the that power plant also. Now therefore this dot system is very necessary. Okay, so let's see what is this actually. For proper combustion of fuel within the boiler, it is necessary that air should continuously blow through the grates. The air flow depend upon the pressure difference between the inside and outside of the boiler grate. Okay, this is I think you know already. The small static pressure difference which causes the flow of gas to take place is termed as a draught. Okay, let me tell you again. Draught. What is draught? A small static pressure difference which causes a flow of gas to take place is termed as draught, and its function in case of boiler is to force air to the fire and to carry away the gaseous product of combustion. The draught is produced discharge of hot gases to atmosphere to draw the resulting hot gases through the system and provide adequate supply of fresh air to the combustion chamber. The draught is measured by U-tube manometer. The amount of draught produced depend on first, rate of combustion process, design of combustion chamber and type of burning fuel, nature of fuel and its depth on the grate, and resistance in flue gas circuit offered by baffle economizer. Okay, we see that what is draught? It is the pressure difference which makes the flue gases to flow outside the boiler. Okay, this is what the draught is. Okay, by the way, it is depend on how the combustion of fuel takes place, then design of combustion chamber and type of burning fuel. Okay, if the fuel is burning fuel is oil, in that case total fuel get converted into gases form. Okay, that means carbon dioxide and carbon, there is no or very less black carbon residue is there. But in case of coal, the carbon is deposition is more. That's why the different dot system is used for different power plant. Then natural nature of fuel and its depth on the grid, then resistance in flue gases circuit offered by the baffle economizer, etc. Okay, that means if the soot particle or gas is trapped by the these baffles and economizer, or we can say tubings, it will fall into the furnace again. That's why this is draught system is also depend on these things. Okay, draught system, natural or chimney draught and artificial draught. Like natural draught is what? The draught used in generally on the jaggery mill, you can see there the natural draught system is used because there is no higher combustion rate and low fuel burning is there. That's why there is no necessary of efficiency and all this stuff. Therefore the draught system is not very good, and the exhaust gases goes naturally because of the difference in temperature, that is difference in density. Okay, this draught or exhaust gases flow out easily without any external firing. Okay, but draught which is artificial draught, there are two types: steam jet draught and mechanical fan draught. In steam jet draught, there are again two types: induced steam jet draught and forced steam jet draught. And then in mechanical, induced fan draught and forced fan draught. Okay, necessity of boiler draught. Why these boiler draughts are necessary? Let's see them. The main purpose to produce a draft in a boiler is to supply sufficient quantity of fresh air for combustion and remove the combustible burnt product from the system. Then, to increase the mass flow rate of the air through fuel bed, which increase the rate of combustion, and to increase the produce flow of hot gases through boiler, economizer, preheater and chimney. A chimney requires a difference of pressure equal to that accelerate the burnt gases to their final velocity, and to overcome the pressure losses equivalent to pressure head draft is necessary. The natural draught, first one of the type, natural draught is produced by the use of chimney. hence it is known as chimney dot also. The natural dot occurs due to the temperature difference and density between the column of hot gases in the chimney and column of air outside the chimney. The density of cold air is more than the density of hot air. So the pressure difference creates which result in flow of hot gases from chimney to atmosphere. The atmospheric air rushing inside the furnace will be utilized for combustion of fuel in furnace also. The amount of draught produced in the boiler depend on atmospheric condition, height of chimney and furnace temperature. Okay, these are the factor which may or which are affecting the draught from the chimney, which is the natural type. The draught produced decreases with increasing outside temperature of air. That means you can say the draught will be removed easily in winter as compared to summer, because if the temperature is higher, less efficient draught removal is will be there, and if in winter low temperature is there in the atmosphere, that's why the draught removal or the combustible or combustion after combustion gases are easy to remove in the winter season. Then when the draft is produced with the hilltop chimney is known as natural draught. Then it doesn't require any external power for producing this draft. Okay, this a natural type of draft system, as this process is taking place by convection method. Okay, natural convection, not forced. It is taking place by natural convection, therefore we don't need any fan or external device to force out that combustible matter. Okay, there is a natural circulation of air through furnace, economizer, air preheater and to the chimney. It is generally depend on height of chimney, as atmospheric pressure is decreased above the earth's surface. Okay, then next one is mechanical dot. Okay, mechanical dot, it is an artificial dot when fuel burning rate is very high. Natural dot are insufficient. Mechanical dot are of three types. Okay, here you can see what happened in case of natural convection or natural dot. If the combustion rate is sufficiently high, in that case this natural convection will fail to draw out all the combustible matter or all after combustion matter through to the atmosphere. Then in that case we need to use any external source for firing out all this combustible matter outside the furnace or boiler. That's why we use fan. Okay, these three type of mechanical dot are there: induced dot, forced dot and bias dot, that is induced and forced, which are used simultaneously. Okay, first one is induced drought. Induced drought is produced by placing a fan near the base of chimney. The fan draws the air through the furnace by reducing the pressure in the furnace below that of atmospheric pressure, which create partial vacuum in furnace, and the flue, the product of combustion, are drawn from the main flue and they pass up the chimney. This type of draught used at economizer and air preheater. Forced draught. This draught is produced by installing the fan or blower near the base of grate and to force the air through the cool bed and other passages. The fan creates pressure higher than the atmospheric in the furnace. It is a positive pressure dot, and above us negative pressure dot, as it was creating vacuum. Next one is balance drought. It is a combination of force and induced drought. The induced drought remove gases from furnace, and forced drought forces or overcomes the resistance of the fuel bed. So sufficient air is supplied for complete combustion of fuel. Then balance drought, just we have seen. What is it? It is the combination of force and induced drought. The induced drought remove gases from furnace, and forced drought forces are overcome the resistance of the fuel bed, and then the sufficient air is supplied for complete combustion of fuel. Advantages of this mechanical over natural: reduce fuel consumption due to complete combustion, easy control on combustion and evaporation, it is independent of climatic condition, and no change of air leakage into furnace as pressure inside the furnace is always above atmospheric pressure. Okay, that's why this natural this forced dot is used instead of natural dot. But there is one disadvantage we can say, or drawback of using this forced drought is what it uses the fan for drawing out that combustible matter. For that we need to supply electricity. Okay, that means the efficiency of the power plant get reduced. Why reduced? Because we are using the generated electricity for running this fan, or we can use even the steam for running this fan. Okay, for running this fan we need steam or electricity. That's why uh, it will also lead to the reduction in efficiency of the boiler. Okay, but quite in smaller quantity. Okay, so this was about the packaged boiler, that means smaller boiler which we use in industry, and the draught system. Okay, that is natural and mechanical type. In next lecture we will study about some Indian boiler regulation acts, and different boiler mounting and boiler accessories. Only this one topic is remaining in this unit, then we will finish this lecture unit. Okay, thank you. Today we stop here.